In one of the example before, we have discussed how do we find the shortest distance between a point P away from the line L. So we start with PR, the vector PR dot B. B is the direction vector of the line that we have, and PR dot B must be 0 because shortest distance PR must be perpendicular to the line. In a similar way, if we want to find the shortest distance between two parallel lines, so we have two parallel lines. Let's say we have line 2 and then line 1. So if we want to find the shortest distance between the two parallel lines, this dotted line here must be perpendicular to line 2, and the dotted line must be perpendicular to line 1 in order to find the shortest distance. So we still use the same method as how to find the shortest distance between a point and a line. That means we need a fixed point P, and point P is known, and we want a point R so that PR is perpendicular to the direction of line 2, and we would use the same formula. PR, vector PR dot B must be 0 in order to find the shortest distance here. So if you know point R, point P is a fixed point we know, then we can find the modulus of PR. That will be the shortest distance between two parallel lines. Meaning to say, we will be using PR dot B equals to 0 to find shortest distance between a point and a line, and also shortest distance between two parallel lines. Let's look at an example here. Line 1, XYZ equals to 0, 3, minus 1 plus lambda 682, and line 2 has column vector equation XYZ equals to 201 plus mu 341. By inspection, you can see that direction of line 1, 682 is actually k times of the direction of line 2, 341. Therefore, line 1 and line 2 are parallels. Let's try to represent line 1 and line 2 in a diagram. Line 2, line 1, and I need point P in line 1. So P is a fixed point in line 1. So I would want to choose 0, 3, minus 1. Because line 1 passes through the fixed point 0, 3, minus 1. So we choose a fixed point in line 1 as 0, 3, 1. So if you don't want to choose this fixed point, you can substitute any value of lambda into line 1 and to get a fixed point to start. And the next thing I need to label is the dotted line in the picture, and point R we don't know. We want to figure it out. Point R lies on line 2, and the direction of line 2 is 341. Let's say call it B. So PR, the dotted line, must perpendicular to line 2, and the dotted line must also perpendicular to line 1. So in order to find this shortest distance, we start with PR, the vector PR dot B equals to 0. So we need to find the vector PR. In order to find vector PR, we need position vector of R, and also we need position vector of P. Because P is a fixed point, so OP, position vector of P, is actually 0, 3, 1. Because we don't know what is point R, but point R lies on line 2, so we can use the general point on line 2 to represent OR. That means OR is the general point of line 2, so we can refer to line 2 here. X is 2 plus 3 mu. 2 plus 3 mu. And the general point, the general y coordinates, is 4 mu. And the z coordinate is 1 plus mu. So this is OR. So we want to find PR, which is using OR minus OP. OR is 2 plus 3 mu, 4 mu, 1 plus mu, minus 0, 3, 1. So OR minus OP, which is PR, we will get OP minus 1. So OP is 0, 3 minus 1. And our answer for PR is 2 plus 3 mu, 4 mu minus 3, and 1 plus mu minus negative 1, so that's 2 plus mu. So this is our vector PR. So we do the dot product. PR, vector PR dot B must be 0, equals to 0. So trying to find the dot product here, 3 times 2 plus 3 mu plus 4 times 4 mu minus 3, and followed by 1 times mu plus 2 equals to 0. 3 times 3 mu, 9 mu, 4 times 4 mu, 16, and we have another mu. And for numbers, we have 3 times 2, 4 times minus 3, plus 2, 0. 26 mu is 4. So mu is 4 over 26, that's 2 over 13. So back to the question. Since we know mu is 2 over 13, then we are able to substitute into PR, because magnitude of PR will be the shortest distance between the two parallel lines. So sub mu equals to 2 over 13 into PR, vector PR. And you will get, so don't worry about this fraction. So the shortest distance, between the two parallel lines is, we try to find the magnitude of PR here. You may want to factor 1 over 13 from the fraction. 32, negative 31, and 28. So in order to find the magnitude, it is the same as 1 over 13. And then we find the magnitude of the vectors. 2769 square root over 13. Or it's 4.05 units. And this is the shortest distance between the two parallel lines. In the next video, I will show you how to find the shortest distance between two skewed lines.